Okay, so in this video, we're talking about radian measure. Okay, and it's important to note right here is that it's just another way to measure angles instead of using degrees. That's essentially it. Okay, what we're going to notice is that more and more of our problems are going to be in radians rather than degrees. Okay, so what is one radian, so to speak? Okay, we have a little definition. So it's an angle with its vertex at the center of a circle. So here's our vertex right here that intercepts an arc, right? So here is our lovely arc. And that arc is the equal length to the radius of the circle. So again, notice that my little r here and this little r here are the same. So when those are the same, we have what's known as 1 radian. Okay. So essentially what we're finding is this kind of distance right here all the way around our circle. So how can I use that information? Okay, well, I can convert between degrees and radians, kind of understanding that the equation of the circumference, 2 pi r. Now, for our unit circle, our r we call just 1. So our circumference around our whole circle, so this means the whole circle, would be 2 pi, right? So if I have radians versus degrees, okay, a whole circle, so whole circle, okay, would essentially be 2 pi. Now, in our degrees, if I wanted to make a complete rotation, that would be 360. So we're going to say that these two are equal. Now, if I say that these two are equal, what I can then end up doing is I can divide both sides by a number. So what happens if I divide the right and the left side by 2? If I do that, I will get pi on one side, and 360 divided by 2 leaves us with 180. So essentially, what this is it's half of a circle. So it's half of a circle. What else could I potentially do? Well, I can solve for 1 degree. So I could take that 180 and I could divide it to both sides. So if I did that, essentially pi over 180 is the same as just 1 degree. And this is going to be very useful, right, when we are converting. Now, what else could I do? Right? Come back over here. Now I could divide both sides instead of by 180, I could divide both sides by pi. And if I do that, that means I'm going to have 1 radian is equal to 180 over pi. So these two pieces of information that I'm going to highlight are going to be used in our converting. Okay? So I want you to think about it. I want you to think about kind of pi over 180 degrees over pi is equal to 1 radian. Again, you don't need the word radian, so to speak. Okay, so how can I use these two conversions? All right, so let's start off with converting to radians. So I'll start off with degrees. So 45 degrees. Again, if I know that 1 degree is equal to, the same thing is equal to pi over 180, okay? I would then think, okay, 2 degrees would be 2 of those. So pi over 180 plus pi over 180. So that'd be the same thing as 2 pi over 180. If I said 3 degrees, that means that I would have 3 of these pi over 180s, which is the same thing as just saying 3 pi over 180. So essentially, when you're converting to radians, all you have to do is multiply by this guy. So in order to convert 45 to radians, I'm going to multiply by pi over 180. Now my degrees will eventually cancel each other out, and I'll be left with my answer. Now, say you don't know how many times 45 goes into 180. What you do know is that 45 is made up of 5 times 9 times pi, And you know that 180 is made up of 9 times 20, right? So what do we know? I know that the 9's cancel out, and I know that the 5 goes into 20 4 times. So that means 45 degrees is the same thing as pi over 4. Okay. Again, eventually you'll have this memorized, but this is just one way to look at it. Okay. So let's try a second one. What happens if I have 30 degrees? So again, I'm going to multiply by pi over 180. Again, this time, let me change my color. My 0 will cancel out. So really 3 goes in to 18 6 times. So that means my answer is just pi over 6. Now, we are assuming that it's radians. If we want to write the word radians, we can. It's not necessary because when we don't have the degree symbol, we always are assuming that it's in radians. Okay. Now, a question we might ask ourselves is, will their coefficients always just be 1 in front of that pi? And the answer is no. So let's try, let's go the opposite direction. So what happens if I want to convert to degrees? Okay, so I'm given my radians. Well, if we recall, 1 radian is the same as 180 over pi, which means that 2 radians would be the same thing as saying 180 plus pi, and then another 180 plus pi, and so forth, and so on. So essentially, this would be like saying 2 times 180 over pi. So when we are converting to degrees, all we have to do is multiply by 180 over pi. So let's take a look at what that looks like. So 9 pi over 4. Okay, so I'm going to go ahead and I'm going to multiply this by 180 all over pi. Okay, so what do I know? Well, first off, my pi's are going to cancel away right away. Okay, and again, if we didn't know how many times 4 went into 180, we can break it down again. But 4 goes into 180 45 times. So essentially, all we're doing is we're multiplying 9 times 45. And if I do that, I will get 405. Now, don't forget to include the degree symbol, because again, we're converting to degrees. All right, let's try another one. What happens if I wanted to know what 3 pi over 2 was? So again, what I'm going to do is I'm going to multiply this by 180 all over pi. I will notice, again, that my pi's will cancel away. 2 goes evenly into 180 90 times. So essentially all you're doing is you're multiplying 3 times 90, which gives us a grand total of 270 degrees. So why is this so important? Well, it's all leading up to our unit circle, and our unit circle has both degrees and radians. So what I want us to do now is I want us to find the value of each function. Okay, so here's our first problem. We're going to find the tangent of 2 pi over 3. Now, we are going to run into a problem because we don't know what quadrant 2 pi over 3 is in, okay? So what I want to first do is I want to first figure out what is 2 pi over 3 in a degree. So I'm going to come over here, and I'm going to multiply 2 pi over 3 by 180 over pi. And what are we going to notice? Our pi's will cancel out, and 3 will go into 180 60 times. So essentially, what we are going to do is we're going to multiply 2 times 60 to give us 120. So tangent of 2 pi over 3 is the same thing as saying the tangent of 120. All right, now 120 I do know. I know some stuff about that. I know that 120 is in the second quadrant. That angle right there, that's 120. I also know that the reference angle is 180 minus 120, which means the reference angle is 60 degrees. So what does that tell me? I can create a triangle, put a little 60 degrees right there. And off of 60 degrees is always my root 3. This will be positive because notice I'm going up. My hypotenuse is always positive, so I'll include that as a 2. And my x, again, if I think about this as a coordinate grid, the x will be negative on the negative side. So what do I know about tangent? Tangent is opposite over adjacent, or aka y over x, either one. So that means opposite is root 3 divided by negative 1. So this answer will be a root 3 over negative 1, or purely just a negative root 3. Okay. So again, we're trying to figure out kind of what is happening using our values of each function. All right, so let's try another one. Call this example number 2. Let's say the cosine of 5 pi over 4. So again, if you want to pause the video, try this one out on your own, feel free. Okay, so again, the first thing, I don't know where 5 pi over 4 is. So I'm going to go ahead and multiply that by 180 over pi. So again, my pi's will cancel away. 4 goes into 180 45 times. And we are going to multiply our 5 times 45, which gives us 225. So again, this would be the same thing as the cosine of 225 degrees. All right, so again, I know some information about 225. What do I know about 225? Well, first off, I know that it's in the third quadrant. All of that angle right there is 225. The next thing I know is my reference angle can be found by saying 225 minus 180. So my reference angle is 45 degrees. So I get to create my right triangle, and I'm going to put a little 45 right there. Again, my x and my y this time are negative, so I'll call them negative 1. And then my hypotenuse is still always positive. So this time I want cosine. Okay, cosine is either adjacent over hypotenuse, or I can say x over r. Either one is perfectly fine. So luckily for us, our x and our y are exactly the same. So negative 1 over root 2. I will rationalize top and bottom. So I will get a grand total of negative root 2 over 2 as my answer. Okay, let's try one more with sine. So let's try one more. And get my pen up. Okay, so what happens if I want my third example, sine of pi? Okay, so yeah, if you want to try pausing the video, go right ahead. So luckily, one of the first things that we recall is that half of a circle is pi over 180. So this would be the same thing as saying the sine of 180 degrees. Now 180, I can't create a right triangle, but I know 180 is on this line right here. So again, if I have a point, we'll call it negative 1, 0. Sine is made up of y over r. So this will be 0 over 1. Doesn't really matter what it is, because ultimately 0 over 1 gives you a plain old 0. Okay, so pretty much the rest of these kind of look very similar, right? So if you are feeling good about these, feel free to stop the video, but if you want some extra examples, then you can stay on and watch them. So extra examples. Again, my suggestion would be try a couple of these on your own, pausing the video and seeing what we get. Okay, so I'll call this extra example. So this will be number 4. So what happens if I want, say, the cotangent of pi over 3? So the first thing I'm going to do, I am going to convert this to my degrees. So 180 over pi. Again, the pi's will cancel away. 3 goes into 180 60 times. So this will be the same thing as cotangent of 60 degrees. So what do I know about 60 degrees? I know it's in my first quadrant. It's like very exciting stuff. So cotangent 60 degrees, this will just be a root 3. This will be a 2. This will be a 1. Okay, now cotangent is the reciprocal of tangent. So if I know tangent is opposite over adjacent, or aka y over x, then cotangent is adjacent over opposite, or aka x over y. Either one does not matter. So that means I'm going to take my x, which is 1, over my y, which was root 3. Again, I'm going to rationalize my denominator. That 3 kind of looks like a snake. So this answer will be root 3 over 3. All right, let's go ahead and try another one. What happens if I give you that looks something like this? Let's do the secant of negative 4 pi over 3. Ooh, negatives. We can still set it up the same exact way. Again, if you want to pause the video, please do so. If not, pay attention. So I'm going to go ahead and I'm going to multiply it by pi, 180 over pi. My pi's are going to cancel. 3 will go into 180, again, 60 times. So this is really negative 4 times 60, which gives me negative 240. Now, negative 240, I'm not quite sure what quadrant that is, so I'm going to find the coterminal angle. So I'm going to add 360 to it. And that is going to leave me with 120. So, what do I know? 120. Here we go. Now, I've already actually seen 120 degrees earlier. So I already know that my reference angle is 60. So this again will be root 3. This will be a negative 1. And this will be a 2. So again, what do I know about secant? I know secant is made up of r over x. So this time it should be 2 over negative 1, or aka negative 2. Right? Let's try one more. Call this number 6. So I've done secant. I think the only one I haven't done is a cosecant. So let's do cosecant of 3 pi over 4. All right, so again, the first thing I'm going to do is I'm going to change 3 pi over 4 into a degree. So again, my pi's will cancel away. 4 goes into 180 45 times. So this is the same as saying 3 times 45 degrees, which is 135. Again, what do I know about 135? We haven't seen this one yet. It's in my second quadrant. I keep picking second quadrants, not on purpose. I'm just thinking these numbers. So 135. I need to find my reference angle, so I'm going to say 180 minus 135. This will give me my lovely reference angle of 45 degrees. My y is positive. My hypotenuse is also positive, but my x is negative. What do I know about cosecant? I know that cosecant is made up of r over y this time. And so then that means that this will be a root 2 over 1, or aka just root 2. So there are 3 more examples of how we can use our method of changing radians first to degrees and then still using 6 of our trig functions. And all of our radians are going to give us degrees that are going to be either created from using our 30, 60, 90 triangles, or 45, 45 triangles, or they're going to be on the quadrantals, so 0, 90, 180, and 270. So now you can do your work, your classwork for 3.1. Good luck.